Hello, class. Welcome to week 7. This week is pretty much the week that we cover living primates, which will be extensive. There's 3 videos for the week, which are excellent. I definitely recommend watching all 3 of them all the way through. Um, they will provide a lot of insight into our primate relatives. So, what is a primate? These are the 3 characteristics. When we come back from the midterm, we'll talk about the development of primates and proto-primates. Primates actually develop out of kind of squirrel, rat-like tree-dwelling creature. And the distinction, and this is just good kind of front loading as a terminology, is the post-orbital bar or post-orbital closure. Essentially, the difference that primates, what really distinguishes us is that we have a post-orbital bar or closure, which engulfs or encases our eye. All other animals, outside of horses and a couple others, there's a break inside that bar. So, like dogs, cats have a tiny break. They don't have that. So, you can essentially press on kind of the eyeball of these other animals and not hit bone. And what that leads me to is the arboreal and adaptation. And really, what we get into is you have to have very good eyes in order to do um, some of the brachiation and tactics that primates use in the trees in order to not fall and die. Um, so, arboreal adaptation, again, a lot of those are it's physical traits that enable organisms to live in the trees. And what we have, and we'll get into more of this, and I'll repeat myself throughout this video, which is totally fine because it helps with the learning process. Is our eyes are essentially in front of our head, and our noses are never too big. In fact, again, if you look at this Duke Langer here, Duke Langers are common in Vietnam, although their habitat is being destroyed. The nose is actually out of the way of the eyes, and having your eyes closer together creates what we call binocular vision, so that you have depth perception. So essentially, your vision, your left eye and your right eye cross, so that you have depth perception. Also, we have precision grip and power grip. So precision grip, we can grab things with our fingertips, and all primates have opposable thumbs. And then the power grip, you can grip onto trees. And then we'll talk about some distinctions between humans and other primates as we move forward. The other thing that primates definitely have is something that's called dietary plasticity, um, and which is flexibility in adapting to a given environment's food resources. And what that means is humans specifically have probably the most plasticity within our diets. Essentially, we can eat kind of everything on the planet that isn't poisonous to us. And even things like acorns that have a lot of tannins that would make us throw up, we leach the poison out of them in order to eat them. So dietary plasticity is going to come into a major as a major component to primates and also the development of Homo sapiens when we move into human evolution. Um, some primates are very, again, there's plasticity, but different primates are specialists in terms of food. So some primates are what we call folivores that eat primarily leaves, like gorillas. Then you have frugivores, which are fruit-eating primates, insectivores that are eating insects, and then you have again, there's no primate that is considered a carnivore. These are your kind of big cats that roam Africa or whatnot. But definitely on the omnivore side, which are humans, right? Which is we could eat plants and animal proteins. The other big one that comes up is parental investment, which is time and energy parents expend for their offspring's benefit. Um, this is going to play into that social cultural side and language development. So the more time that we spend with our parents, essentially the more time they have to teach us. And as you watch Ape Genius, you're gonna see a lot of some interesting things that start to separate us out from our bonobo relatives and our chimp relatives, based on kind of the parental investment, but also what that actually means in terms of brain development and growth. So primate adaptation, again, generalized skeletal structure. Many primates have longer arms than legs and or of equal size. Humans' legs are longer. And this is basically our gait structure, which is in order to walk and or run. Again, I talked about enhanced touch. So this is enhanced touch in terms of precision grip. We have fingerprints, which give us a little bit more feeling as well. Enhanced vision, kind of already covered it, binocular vision. Out of that, because our evolution or our change in development has shifted so much towards vision, in that we've lost a lot of our sense of smell. So a lot of, again, you don't necessarily, and I've never seen this, canine units are used because dogs have a keen sense of smell. They don't see as well as we do, but you never see a primate being used, even though they can kind of move better around luggage in an airport, as a sniffing animal. Our noses have essentially reduced because our eyes have been enhanced. And again, it's through genetic variation, natural selection, mutation, some of those other things. But even if you look at like a raccoon or a squirrel, you're going to start to see, and even in types of rats, you'll see that their vision is actually much more enhanced. Rats, I believe, though, have black and white vision, which again is not set up for tree-dwelling creatures, because then you're not actually able to see ripe fruit. And we'll get into some of these other theories as well. But again, definitely more on the squirrel raccoon side of the kind of mammal kingdom. You see some interesting stuff. Dietary versatility or plasticity also covered, and then parental investment. This slide's vitally important in terms of primate adaptation, right? Like, what is it that makes us us, and then how are we related to, again, non-human primates? So parts of the skeletal structure, this tarsier, people either think that it's cute or scary. Obviously, this particular animal is out during the day, or this camera has a very good flash, but this particular primate is nocturnal, is set up for the night, and you can see the dilation of the pupils, or the lack thereof. Super, super small, because essentially the goal is to not allow a lot of light in. But that whole eyeball there of that tarsier can essentially open up and be one giant pupil, bringing in all the light for nocturnal seeing. Some of the things in terms of skeletal structure is the shoulders, the clavicle, and the scapula allow us to move our arms all the way around. And not all animals can do this, right? I mean, especially true quadrupeds like dogs and cats. Their range of motion with their shoulders do not allow the kind of brachiation with the trees. Limbs, our radius and ulna. Our radius and ulna are in our arm. Again, I haven't forced you guys to do too much with osteology. Your ulna runs up kind of the backside of your forearm up to your pinky. The radius runs toward your thumb. But what it allows us to do, the way that we have our elbows situated, and these bones, how they rotate, is we can move our arm a lot of, we have a lot of rotation ability. So again, the radius and ulna are also key. Hands, we have our fingers. Again, our fingers, the other thing that makes primates is that we have fingernails instead of claws. Everything outside of the primate kingdom typically has claws. I mean, if you look at a cat or even kind of a dog, we call them, those are definitely more claw structure rather than on top for gripping, right? Fingernails essentially give us a backing. So when we put pressure on our fingers, it backs that pressure. When you have claws, you can't actually put a lot of pressure necessarily on the fingers. So your fingers are made to take a lot of pressure. Every primate outside of us has an opposable big toe. And again, this is an interesting thing, right? Like, so chimps, you'll see them walk, and their feet actually look like this because their opposable big toe is used for gripping. Our feet don't do that anymore because we've evolved more or changed to terrestrial life. Um, we definitely have a reduced snout size, and smell has basically, again, taken a hit for that. But our vision and touch have become more important. So touching and vision have become more important. Fascinating component with touch, right, is we lose our ability to smell. Even though a lot of our smell senses are things that we're unconscious of, things like pheromones and some interesting things like that. But touch becomes very, very important for things like oxytocin, which is kind of your love trust hormone that is produced with human touch, and touch in general, right? Like cats, when you pet them, there's a touch kind of sensory system that goes off and creates a purr. So again, humans having that more increased ability to touch, and then essentially also not having hair and being what many call the naked ape, allows us to actually access more oxytocin with skin to skin contact. Brachiators, the idea here is the term is brachiation, and this is a type of movement, especially within trees. So gibbons and siamings use upper limbs to swing from branch to branch, and this is your typical. If you can imagine, it's basically what we do when we do our monkey bars exercise. As an adult, those become very difficult. I tried with my niece and nephew just a couple months ago, and they are way better than I am. So again, but if you Google or look up these primates like gibbons or siamings, they're masters of kind of this style of brachiation, which is limb over limb movement through the trees. Part of that kind of enhanced touch, again, we have the opposable thumb, power grip, right, gripping something like a hammer, and then we have the precision grip with our fingertips. Again, you can do minutia, anything kind of you want with this structure. It allows for us to use like major tool use. The opposable big toes again act as kind of this their feet act as two sets of other hands, and this is advantageous for trees. Humans are not great tree climbers. This is why we have movies like Pollyanna and some of these other things. But also, the monkey bars are one of those. It's a piece of equipment that is essentially trying to test out our ability to kind of brachiate and return back to kind of this tree dwelling process. Which again, like I said, I am definitely not good at it. Enhanced vision, reduced smell. Nocturnal organisms, these are terms that you're definitely going to want to know. Nocturnal is night dwelling, and there's definitely plenty of primates that are night dwelling. And then you have diurnal, which are organisms or creatures that are for the day, right? They basically live through the day. We are diurnal. We are not nocturnal animals. Absolutely not nocturnal animals. In fact, everything bad in our human world tends to happen at night. But diurnal and daytime operation again sets us up for niche time periods, and then that adaptation and or nocturnalness adds up to some of your night primates. Again, if you think of the bird kingdom, there's not a lot of birds that are adapted to the night, and that's why the owls tend to get a lot of attention, because they are night creatures, taking advantage of kind of that night day dichotomy, really. What is fascinating is that some animals are both, like cats. Cats and foxes have the same types of eyes, that they are diurnal and nocturnal. And again, their pupils are usually vertical in order to keep light differentiation out. It's quite fascinating to me. The rhinarium is basically the nose that is, they call it the naked rhinarium, which is essentially your nostrils are wet. Again, cats, dogs have naked rhinariums. Many of, again, the primates tend to have dry, right? And again, the higher level primates have lost their naked rhinarium. Lower levels end up having that wet nose. And the wet nose, just so you know, this kind of rhinarium structure allows for enhanced smell. So those primates that do have it are going to have better smell than those that don't. We have kind of that dry version of nostrils, and we're not great smellers at all.